Okay, I'd like to take my few minutes to invite you to go back to high school, or for some of you back to kindergarten, when there was a sort of simple concept of what a good scientist did. A good scientist produced results based on data that were expected to be freely shared and scrutinized by others. And the force of the scientific conclusion derived from the openness of the data and the transparency of the analysis. As we grow up, many of us start to encounter the real world and lose that simplistic concept. But I think it's a very useful concept to return to. If a graduate student says to me, "But Tony, you don't understand, I plan to base my future career on mining this data that I've so painstakingly collected, and I'm certainly not going to share it with other people, there goes my career," what I would say is, you haven't paid the price of entry. The price of entry to being a real scientist is you do things in the open light. You don't monopolize them. Okay, let's look at the current situation. I think that this issue of should we share data and how should we share it, two different issues, should be framed in the context of where we are right now. And where we are right now is that there's an epidemic of false positive results, typically exciting results, publishable results, newsworthy results, and those things tend to go together, but not correct results. So I've here shown three, but they're three of many hand-wringing articles from the last few years. Perhaps one of the most famous, anyway, it goes clear back to 2005, Why Most Published Research Findings Are False. Great title. In the middle, Trials and Errors, Why Science is Failing Us, basically because people are overconfident about causal interpretations of ambiguous data. And then on the right, a opinion piece from Nature a couple of years ago, Beware the Creeping Cracks of Bias, saying, gee, an awful lot of published results aren't right, they're not credible, and that's bad for everyone. And as George already mentioned, so I'm not going to go through this, there are 101 reasons why different investigators might reach different conclusions from the same data. But what's going to be really important is to show the audit trail that leads to particular conclusions. Ellen earlier raised the question, what is data? I would say, well, if a regulatory agency says, we're going to do this because the relative risk is 2.2, the relevant data are the complete audit trail that end with 2.2 and go back through the chain of calculations, ultimately to raw data. What surveys were handed out and what were the results on the survey. If you can't audit the result, you don't know that it's correct. Now, I'm using the word audit. It's got a legalistic connotation. But again, this is the high school or perhaps kindergarten idea of science, that results flow from publicly available, reproducible, everybody can stand around and look at it, data. Asking members of professional societies who are engaged in risk analysis, my passion, 69% said that to them it was very important to have access to the underlying raw data so they could form their own conclusions. Independent-minded bunch. But only 36% said that having this access was typically the case. So at least there's a perception of a big gap between what you would want to do a responsible job of coming to conclusions and what we currently have. I hypothesize. Now, I wish I could share with you empirical results, but unfortunately the data are confidential. No, I don't have any data. I hypothesize, in the absence of data, but just applying common sense, that open access to key data, meaning the data that flows through calculations to produce results that are relied on, not only for regulatory purposes, but for any decision-making purposes, public decision-making, excuse me, that open access to key data and also models will encourage greater scrutiny. Other people will say, well, let me see if I can come up with the same answer, or let me see if I don't make these assumptions, suppose I make some other assumptions, would I get a very different answer? Let's go find out. And I think that more careful scrutiny would encourage more careful research, a lower prevalence of false positives. This is a very, very serious problem. The problem of non-reproducibility perhaps pales in comparison to the problem of false positives. That more careful research will be accompanied by more careful interpretation. Don't over-interpret the data. Don't draw causal conclusions from associations that aren't necessarily causal, and hence increase trustworthiness of published results. And ladies and gentlemen, this is a pearl of great price. We need greater trustworthiness in published results and in actions taken based on them. So that's one class of benefits. I came here to talk about benefits, that's one. The other class, I think, is that by lowering the barriers to entry to reanalysis or alternative analyses. We encourage better and more frequent follow-up. We increase the value from the investments that have already been made in research. It is very costly to assemble a good database, so let's have a lot of people exploit that database to get as much juice out of it as possible. Okay, so those are two classes of benefits that I think are important. There's some possible pros and cons that we'll discuss throughout the day for data transparency. Briefly, I would say that the burden on researchers should not be a burden. Researchers should expect that their results will be scrutinized and their data will be scrutinized. That's should be the price of entry to doing good science. The concern that Linda expressed, that individual privacy, no matter how you screw up the data, that you're still going to be able to, you still can't protect privacy, I don't think that's true. I think we need to give respect where it's due to folks who've worked on statistical methods for getting sound statistical inferences without disclosing individual information. And finally, the concern that unscrupulous or motivated investigators might do schlocky analysis to distort public policy, I think that's part of the price of democracy. We should have people arguing about whether analysis is good. That's a perfect place to focus. Okay, I'll close by alluding to a large literature on statistical disclosure control that I think provides appropriate technical methods for technical problems. I'll mention, as some people have touched on, that journals are heading in the direction of greater transparency. In particular, Marcia McNutt in Science notes the troubling proportion of peer-reviewed studies that are not reproducible and calls for increased transparency, and in particular, teaming up with the American Statistical Association to remedy that problem. Last slide, making key data used to support decisions widely available has important potential benefits in improving both original research, because you know someone will be looking over your shoulder, and also follow-up research. My proposal, the one I would leave you with, is that sharing data upon request should be the rule, not the exception. That should be the general expectation of good science. Thank you.